In this video, we'll demonstrate how to accelerate media pipelines with cloud-integrated batch rendering leveraging Elastifile. Rendering jobs can generate demanding compute and storage requirements. These requirements can easily saturate on-premises resources, making rendering a critical media pipeline bottleneck. And to avoid these bottlenecks, public cloud can be leveraged to accelerate these media pipelines. And in this demo, we're going to illustrate just such a workflow using Elastifile. Here you see the model that we'll be rendering. The first thing we're going to do is render using on-prem resources. We'll start with a 3-node render farm with 12 CPU cores on-prem, and we're going to measure the wall clock time for our render. Then we're going to compare that to the end-to-end wall clock time for a cloud-integrated workflow. Now, our job is 145 frames, and you can see it's fully loading the on-prem resources. After 5 hours, our on-prem farm is still working on the first dozen frames. So we're going to pause that job because it'd take over 50 hours, and we're going to go to our cloud-integrated flow. In that flow, we're going to first stage the assets in cost-effective object storage, enabling us to batch our render jobs. Now, before we stage any data in the cloud, we're going to start our timer, which is going to run continuously to show the time for the full end-to-end cloud-integrated workflow. First, we're going to leverage Cloud Connect to create a data link between our on-prem environment and cloud. With the link created, we'll now stage our assets in cloud-based object storage for later use. Now, the object data has been created. You can see the whole process took only about 2 minutes. Now, in this demo, we're staging data from a single user, but Cloud Connect can also support multiple users and sites. With the data staged, we'll deploy our processing infrastructure and load data into Elastifile for use by existing rendering apps with no changes required. Now, to demonstrate our API-based automation, we're going to spin up our infrastructure this time using a Terraform script. As you can see, in minutes, an Elastifile storage cluster is fully deployed. Then our script's going to move on and deploy the compute infrastructure that we need to execute our rendering job. Now, in the cloud, we're going to create a 6-node render farm with a total of 384 CPU cores. And here you can see we navigate to the Elastifile UI, where storage can be easily monitored and managed. And we're going to execute one final script to load the data from object storage into the Elastifile file system. Now, this checkout process also leverages Cloud Connect, but this time we bypassed UI-based control in favor of API-based automation. Now, with the data loaded into the Elastifile file system, we kick off our cloud-based rendering job. As you can see, even using the more powerful cloud-based render farm, the CPUs are still fully utilized. But with additional parallel resources available in the cloud, our render farm is executing the job much more quickly. In the cloud, we finished rendering all 145 frames in under 3.5 hours, compared to the 50+ hours that were required on-prem. Now, with the job completed, we can now view all 145 rendered frames in our output directory. And in the Elastifile Management UI, we can see the storage performance statistics associated with our rendering job. These stats can be viewed in real time or after the fact. And here we see the history of read and write activity corresponding to data loads and data writes. Finally, we get to view our fully rendered animation. And with that, we've demonstrated how Elastifile can be leveraged to implement cloud-integrated media pipelines and eliminate rendering bottlenecks. Thank you.